Hey everybody, it's getting to be a little past 10:05 here, so we're going to go ahead and kick off the presentation. I just wanted to say hi to everybody and thank you again for attending and taking the time out of your busy day to join me for our third and final part of our web series on Azure Site Recovery. In this session, we're going to discuss how we have brought other infrastructure items into Azure Site Recovery plans for some of our other clients, along with native virtual machines that Azure Site Recovery transports very well, and some deeper integration into Azure Automation by deploying a hybrid runbook worker to make changes to corporate-owned and managed items during live and test failovers to join other existing infrastructure in our VMs together to bring up these services in tiers. So a little bit of housekeeping work first. Who we are Model Technology Solutions, and we were founded in 2014 by engineers. We are delivery focused, not sales focused. We have a project delivery team to handle things like Azure IaaS transitions, Office 365 migrations, Azure Site Recovery implementations, Windows automation, Windows automated patching, operating system deployment, and System Center Configuration Manager, and the list goes on. We have a managed services team that is an extension of your internal team to help with products such as System Center Configuration Manager, operating system deployment, Windows patching, and application deployment, just to name a few. We are cloud embracing. We want to help you determine what workloads to transition, how to transition them, and how to manage them post-migration. Our mission statement: empower our partners through services, automation, and optimization to become infrastructure heroes. Who am I? For the third straight week in a row, I'm Nick Taylor, and I'm still a nerd. I'm still happy to be sitting in mission control there, just chilling in Gene Kranz's chair like a boss. Things that I enjoy, nerd things. I like the cloud, I like virtualization, I like automation. I honestly think I enjoy the cloud as much as I do because of its similarities to the shift to virtualization, like a decade ago? It's just another one of those crazy shifts in how we manage and deliver services to ourselves in IT and to our end users. And it's still really in its infancy. So it's a super exciting time to be part of all this, manage these migrations, and see how they're happening, moving these workloads into the cloud. I've been doing this for about 2 decades, and hopefully we'll do it again for about 2 more. So our webinar overview for today and our other parts in the series: Part 1 was an introduction to Azure Site Recovery, some of its terminology, topology, configuration, and a high-level overview of the solution itself. Part 2 was a bit more advanced functionality and configuration. We discussed different failover types and how we could leverage those to do some application sandboxing. Here in Part 3, we'll have a little bit of a review, and then some more advanced scripting and bringing in of other infrastructure items into the mix as we transition all of this into Azure IaaS. So our agenda for today: recapping some high-level items from section 1 and 2. That way we can do our final deep dive here in session 3. After a recap, let's look at some advanced use cases. Let's look at options for bringing other items outside of the normal scope of virtual machines into Azure Site Recovery and see how we could integrate them into the process. We will also take a deeper look at some options we have in Azure Automation to assist us with these items and how we can leverage hybrid runbook workers to perform tasks against our corporate-owned and managed environments versus the Azure fabrics we've dealt with so far in the other demos. Okay, so let's dive into some of the details from session 1 and 2 so we can hit the ground running here in session 3. So what was Azure Site Recovery? It's disaster recovery as a service. We're letting Microsoft handle the time-consuming operational details of your disaster recovery data center. We're letting Microsoft handle things like host patching, network patching, security appliance patching, keeping that DR site scaled to your production levels, be that scaling up or scaling down, and not having to worry about those capital expenses and shifting it to more bite-sized monthly operational costs. Really, all of that care and feeding that comes with operating a second data center to serve as disaster recovery. It's also a lift and shift tool. We can use Azure Site Recovery not only for disaster recovery, but to do testing, migration, and failback of virtual machines to and from our Azure IaaS tenant. With that, we get application sandboxing. This is our test failover option that allows us to work inside of a closed and sandboxed environment. We could use this for DR testing. We could use this for testing our in-house applications on Azure Fabrics to measure and gauge their performance before performing a migration. Or we could use it for application upgrade testing, so we could perform the needed steps on our virtual machines and services, script those out to ensure our success when we perform those upgrade operations against our live environment. And we're doing this all while testing our DR process at the same time. So if disaster does strike, we are very comfortable with all the components in play and their related steps to ensure we are as ready as we can be if that day ever does come. So let's discuss some of that terminology. Recovery vaults. They're where we house our configuration to tie in all of our logical sites, host clusters, individual hosts together in our recovery vault. This is where we set all the configuration of replication intervals, failover options for our virtual machines, such as storage accounts, virtual networks, and resource groups. Finally, it's our pane of glass for replicated and backed up objects in Azure Site Recovery and Azure Backup. Some quick health stats, topology overview, and where we can initiate planned failovers on our more complex recovery plans or individual VMs. Speaking of recovery plans, this lets us see what virtual machines come up in what order or tier. So we start with something like an Active Directory tier. Then maybe we add on some storage. Then maybe a database server that's reliant on that storage we just presented. Then possibly a middle tier to connect back into that database. And finally a web tier to connect back to that mid tier. Then maybe we need to bolt on some load balancers and apply some network security groups. We can do all that through custom scripting and the group functionality in those recovery plans. And we could accomplish all of this by and Azure Automation. It's our integrated automation solution that is tied to Azure Site Recovery. This is where we can write and execute custom scripts during our recovery plans. So far, we have discussed and shown how we can configure Azure Fabric items, but today we'll discuss how to target scripts and fire them against our own virtual machines and corporate-owned devices. So now that we've had a quick refresher on a few of those high-level terms, let's take a look at some of the common other items normally in play for our recovery plans that we see in other clients. Load balancers. Load balancers are a fairly common option we configure when implementing ASR. What we mostly run into is whatever flavor the client is using on-premise is what we will try to find in the marketplace first. The most common we run into in the field seem to be NetScalers, F5s, and Kemps, but there are lots and lots of different options out there in the marketplace. If you want to see if your preferred vendor is available for use, just give the marketplace a quick search and take a look, or reach out to that sales team. After we find the preferred vendor, we normally then recommend engaging their sales team, seeing what kind of options we have for licensing in Azure, reusing existing configurations we bring from on-premise, and how to deal with costs in that new environment. Once those decisions are made, we script objects that may be needed, such as the upload of those configurations and the starting and stopping of those devices as part of the recovery plans themselves, and then shut those devices down as we stop those recovery plans. There's no need to pay for a load balancer in Azure when it's not balancing any load. Microsoft, of course, also have load balancers if you want to stay completely inside of their ecosystem while moving into Azure. Another item we regularly see deployed with Azure Site Recovery is edge network devices. Normally, Azure IaaS is treated as an extension of your data center, so most clients stick with what they have deployed at the primary data center itself. A mix of clients also use these devices themselves to configure the site-to-site VPN to Azure. So they deploy a Cisco ASAV, virtual ASA, in Azure to tie back to their more likely hardware-based ASA on-premise to create that link and stretch your data center. We again recommend getting the vendor involved to see what solutions are available and what options we have for config management and licensing. We again look at those options and script out the configs that need to be updated and what changes need to be made if you need to place a security device in front of your Azure tenant in the event of a failover to Azure as your primary data center in a disaster event. Microsoft also has advanced firewalls in the marketplace, and you could use network security groups if their limited functionality works for you at the edge of your network. Storage area networks. For SANs, several vendors have virtual appliances you can deploy to extend your existing SANs functionality on top of Azure storage. When deployed and configured, they can begin the replication of data volumes and snapshots to move this backend data to Azure along with Azure Site Recovery for the transport of your virtual machines. In an instance where you have something like a physical server hosting SQL data that is writing a direct attached LUN, this is a great way to transport that data and assist with DR planning and application testing. Some of the licensing costs of these virtual appliances can be offset with the fact that these virtual appliances do let you perform deduplication or inline compression on Azure storage, and that should cut your monthly storage costs down in Azure a bit. So let's take a look at Azure Automation and how we can affect Azure Fabric or items inside of our own corporate managed domain joined VMs and infrastructure. So what we have done in our demo so far with Azure Automation is out of the box by simply logging into our Azure tenant and executing scripts on Azure Fabric objects. We can do basic actions against anything Azure is aware of and manages. Things like rebooting virtual machines, applying settings to network security groups, or kicking off a recovery plan via a script. If we can see an item and manage it natively in the Azure portal, we can probably use Azure Automation to control it in some way, shape, or form. What we cannot do without additional configuration is perform actions inside of our corporate-owned and domain-joined virtual machines and devices that we bring into Azure. Azure has no clue about the inner workings of your SQL Server virtual machine. It knows the logical name we give it inside of Azure so that it can reboot it or statically assign an IP address based on that object's MAC address, but it can't do things like recover a database or create a user inside of your on-prem Active Directory environment, as it has no tie back into your environment. So this is where hybrid runbook workers come into play. That feature set of working with your items is where these hybrid runbook workers shine. It's an easy configuration that can be set up with a few scripts provided by Microsoft. It's an outbound initiated HTTPS connection, so there's no need to punch more holes in your public firewall as long as you're allowing outbound HTTPS connections. This lets us set up a connection into our environment securely so that scripts can be passed to your virtual machines or appliances to manage your environment. You can think of a hybrid runbook worker as a jump box or a bastion server for Azure environments to get back inside of your corporate network. We also don't have to use Azure Automation and hybrid runbook workers alone with Azure Site Recovery. Once we set up Azure Automation and these hybrid runbook workers, we can use this for all sorts of automation. So it's a great add-on to these projects where we have also just deployed a completely new automation solution for you in-house to manage all of your automation needs. So when we use a hybrid runbook worker in conjunction with Azure, we have all the tools we need at our disposal to automate the needed Azure fabrics and our own fabrics. We could do things like spin up a SQL server in Azure by powering on an IaaS VM. We can then use a hybrid runbook worker to present an iSCSI LUN. We can mount that LUN to that virtual server. Once storage is mounted, we can pass some scripts to restore a SQL database to that new server. That sounds pretty cool, doesn't it? Almost sounds like a great idea for like a demo or a lab of some sort. So let's actually do that. It's one of my favorite use cases, honestly. Just for your knowledge, I started a recovery plan this morning, as VMs usually take around 20 minutes to fail over. Once we discuss the topology of this solution and what we have on-prem and how we're transporting that to Azure in this demo, we'll walk through the results of that recovery plan and I'll show you each of those steps. I also needed to use a Windows server to serve up some iSCSI disk, as I don't have a spare six-figure SAN in my home lab. If you do, I'm totally jealous and you've absolutely beaten me in the cool nerd competition. So let's take a peek at how this infrastructure looks for our demo and how we've executed that recovery plan. We'll look at each script, and finally we'll kick off the remaining scripts and watch how we can bolt that storage into our SQL server, present those volumes, and restore SQL databases on top of them. So let's take a look here at our example configuration. We have our Active Directory controller moving to Azure via Site Recovery. We, of course, can add all of our VMs this way. We could add in IaaS servers, application servers, management servers, jump boxes, any traditional VM that's encapsulated inside of a virtual disk, lift and move that to Azure to be placed inside of our recovery plans and run with our runbooks. We have a hybrid runbook worker that could either live full-time in Azure or on-premise and be part of our recovery plan to restore it to our sandbox. Just as an FYI, if this does live on premise, just make sure to add in a shutdown step for that hybrid runbook worker in your recovery plan so you know for sure where we are executing code. You don't want to accidentally fire test code at your live environment when you think you're playing in this sandbox. Next, we have a physical SQL server tied to a physical SAN with some iSCSI LUNs. In ASR, we could put an agent on that physical server to move it into our vault. But one of our limits in Azure Site Recovery on physical servers is there's no supported failback method for that. So once we would initiate a test or a live failover, there's no going back from the cloud for that machine. And that could definitely prove problematic as we want to test this process over and over and over again. So how do we get around this critical physical box and getting our SQL data replicated and ready for restoration inside of Azure IaaS in our sandbox environment? Well, let's use one of those SAN vendors to replicate that SQL data to Azure. Then let's build out a brand new SQL box in Azure IaaS. Then let's use our hybrid runbook workers to present that SQL data, attach it to our IaaS server, and restore those databases. Okay, so enough talk here in the demo. Let me end this slideshow for a minute, and we will jump into our Azure tenant. First, let's take a look at that recovery plan, and we'll step through what I've already accomplished this morning. So this is our demo recovery plan. As you can see, in the recovery plan, I'm bringing up an Active Directory server. I'm bringing up a Test SQL server. I'm bringing up my hybrid runbook worker. And pay no attention to this being a Windows VM. It's clearly a SAN. It says so right there. Okay, After that, we're going to apply a network security group. As we discussed beforehand, I want to limit some of these connections going back into that sandbox. I want to make sure I'm the only one that can RDP to these servers as I'm giving them public IPs. The IP scheme for Microsoft Azure and the data centers are already fairly well known. And as we saw in session 2, if I leave it open for connections, people will target it and try to log on to my servers. Further in the recovery plan, I'm going to start my Active Directory box, as that's where I start all my recovery plans, as that's one of our base services. After that, I'm going to initiate the starts of my SQL box, hybrid runbook worker, and my for sure SAN device, not a Windows server. After that, I'm going to apply a public IP address for access. In a normal production scenario, I would apply this to a jump box or a management box that has all of my corporate tools to manage these environments there so that users and administrators can navigate around the sandbox environment. In this use case, since I only want to show you objects happening inside of our SQL server, I've bound it directly to that VM. I also need to set some static IPs in this sandbox. I need to know what IP address to connect to for storage to make that iSCSI target. And I always want to know what address my SQL server has. So if I have any updated CNAME records or pointer records that I need to target that SQL server with, I know that statically bound IP. And it finally recovers that plan. So there we go, we've got success on that end. So let's take a quick look at those IP scripts, and I want to show you how they're formatted not to use a hybrid runbook worker and just fire against Azure Fabric. So let's jump over in our automation account here. So as you can see in our automation account, we also get a high-level overview of the scripts that have ran in the past couple of hours, or 24 hours to be exact, and you can see everything was successful from this morning. Not that we have a ton of scripts, but what we're using for test was. So let's drill into runbooks. And in my runbooks, the first thing I do is apply that network security group. So let's give this a peek. And you can see I'm not passing any on-premise credentials. I'm actually using the service principal connections, and I'm logging on to my Azure tenant in using this method. I'm not passing a Windows username from my Active Directory. I'm doing some try catches in here and making sure I successfully log onto my Azure tenant or report a failure in that output. Once I'm there, I'm getting some VNet objects, which Azure is aware of, its subnet objects, network security group objects, and applying all of those to that subnet. And again, throwing some try catches in there so I know output, and I could write terminating errors and failure events to show red throughout my recovery plan if I'd like to on these objects. So that's how we apply our network security group. Let's take a quick look at those IP ones. Here is applying a public IP to our SQL server. And as you can see, again, I'm just authenticating into my Azure tenant, not passing Windows username or password. Again, I'm writing some output, and I am binding a public IP address to my SQL box. All things that Azure is aware of and can manage for me. No need to touch the inside or inner workings of my domain joined virtual machines. And lastly, that other static IP script, which is extremely similar. I'm logging onto my Azure tenant, and I'm performing actions against Azure Fabric items. I'm grabbing the virtual machine names, specifying private IP addresses, setting these values to static, and rebooting those virtual machines. So let's take a look at the VMs that have spun up with this process. So I click over here. You can see that all of my test virtual machines come up with a dash test in their name. So from my virtual machine panes, I kind of know what's running in my sandbox instantly. I probably also know that by the private addressing scheme I'm using, but this gives me a quick look or a quick way to filter on what's actually in use inside of my sandbox. And let's jump into the SQL server that I've got spun up for this environment. And just kind of want to show you that in this instance, I don't have any other disks attached at the moment, just my local C drive and the temporary storage I always get with Azure. Do a little refresh. And you can see in my Scuzzy initiator properties, I don't have any discovered targets, nothing in my discovery tab. I have no favorite targets, no volumes or devices, nothing configured in Radius as it's not in play anyway. And my configuration is only my personal Scuzzy, well, not my personal, this server's Scuzzy initiators name and chap settings. So that's completely blank. And in our SQL server itself, you can see I have no databases. So no smoke, no mirrors here. None of this has been configured or the scripts for this have ran yet. We'll step through those and run them and watch this restoration process happen. So let's go ahead and jump back to Azure Automation. If I can get out of this VM. Go down. There we go. Okay. So back into Azure Automation. And before we jump into those scripts, I just wanted to show you one of the ways that you can securely house and manage passwords here in Azure Automation. If I go down to my shared resources, I have several options for this. I could use credential objects, but in my demo, I'm using variables. In these variables, I've named two, and I can encrypt these variables. So I have an automation password and an automation username. I can create granular usernames and passwords just like I can for any automation solution, and I would highly recommend you do so. You don't want a domain admin performing automated actions against everything. Get that security level granular, delegate rights for those automation accounts just for your SQL boxes. Use those to target your SQL boxes. The same things for workstations, other servers, and specific roles. Keep it as granular as you can. And in each one of these objects, you can see that since it's encrypted, I can't see what this value is. I can change it, I could delete it, but I can't see it right out of the gate. And we'll use these two objects to pass in the scripts I'm just about to show you to actually authenticate against our on-premise VMs and perform these actions. So let's jump into those scripts. Or runbooks, whatever technical name you want to use. The first one we need to do is our iSCSI connection script. This is going to reach out to our SQL Server VM. And you can see here, I'm actually now passing those at our Azure Automation variables, converting them to a secure string, and passing that over to our target server. In this case, it's our SQL Server. Once I'm there, I'm going to fire this via script block, and I am going to set up a new iSCSI portal. I'm passing it the known IP address that we set earlier in our scripts for our quote-unquote SAN. I'm going to make that session true and persistent, and once I do that, I'm going to pass a few more variables. So I have a known disk GUID coming from on-premise from a different server. I run a little bit of PowerShell to grab this disk GUID on-premise, bolt it into my scripts, so that as this moves across into Azure and I'm bolting this onto a new SQL server, I know that my SQL data disk GUID equals this, and I can set my SQL drive letter equal to S. This is a demo environment, so I only have one disk I'm using here. In production, you'd probably be bringing several more along. You'd probably have your SQL data disk, SQL log volumes, SQL system, and we want all of those to have persistent logical drive letters moving from on-prem to Azure, so when we fire our SQL restoration scripts, we know where everything should land. So I'm passing that known disk GUID. I'm passing what drive letter I want that drive to be once it's online. And I'm passing a SQL data path, and we'll show that here in a second. So once I set those variables, I'm going to configure that data disk. I'm going to grab it, and I'm going to set it online. I'm going to make sure it's not read-only. I'm going to make sure it's not hidden. Then I'm going to set that partition to my known drive letter. Once all of that happens, I'm going to reackle that SQL data path. In this use case, I've got a SQL server on-premise connected to that iSCSI LUN. I'm bringing it into a different server, so I'll need to reackle those files so that this new system can take control of them. Once all that happens, do a little bit of try catch and report some errors if that were to happen. So let's run this script and look at its actions performed against our IaaS SQL server. So I'm going to use the test pane functionality up here so I could walk through this script. As you can see, one of our first things we get to pick is whether to run this against Azure Fabric or a hybrid worker. If I were to run this script that relies on my virtual machines against Azure Fabric, it would instantly fail, as Azure has no comprehension of what these objects are I'm trying to pass it to. I'm going to use a hybrid runbook worker. If I have multiple deployed out in my environment, I'd be able to select which one I'd want to use here. Also, in a scriptomatic fashion, I could fire a one-liner and pass a parameter to use this hybrid runbook worker if that's the one I always want to target. In the test pane, I just get to choose. So I'm going to go ahead and click Start here. I'm going to keep my fingers crossed, and may the demo gods be with me. It would be pretty cool not to see red. So you can see the object's queued. It's trying to initiate communication with my hybrid runbook worker. Once we move past this queued stage, we'll begin running this script against that hybrid runbook worker, initiating that script block back out to our SQL server, and performing these actions. All right, cool. We're running. Let's flip over to SQL just so I could show you as it happens. Hey, that happened pretty quick. We've got a SanDisk there now. Didn't even have to refresh. There's a folder there with SQL. I'm going to refresh my Scuzzy targets, which should be there since I have a disk. Cool, and it looks like I just changed drive letters, so it killed my window. Cool, SanDisk there. Scuzzy connection connected. We've now got items in discovery, and we've now got items in our favorite targets. And I've got this SanDisk I brought along with me, with this folder called SQL, and with an MDF and LDF for my SQL log files. So all that storage just got attached into my SQL IaaS server, reactled on the file, and at this point, I should be ready to restore this SQL database. Nothing's happened on that front yet. Let's take a look at SQL Management Studio and just make sure it's still blank. Hey, look, no databases. So let's go next step. Get that banner out of the way. Go away. Go away. Ah, yay. Okay, drop that down. And as you can see, we get a completed and success on our script over here that we ran against our Scuzzy connection and all of its output variables there. So let's jump back and let's look at our SQL restoration process. So let's look at restore SQL DB, which is the next script we'll dive into and fire against our test environment. We'll edit again so we have the option to use our test pane. So as you can see, same way, I'm passing variables from Azure Automation to make secure connections and create a script block going into my SQL server. I'm going to write output so I have so I know that I have successes and failures along the way. And one of the first things I'm going to do is get this XML file. And I'll show you the contents of this XML file in just a minute here. Once I get that XML file, I'm going to recurse through it. And for each of these settings in that XML file, I'm going to start restoring these databases or set variables around them. So let's pop back in that SQL server for just a tick. So I set these to a known path and keep them the same throughout the environment. Right now, I'm just using a C scripts directory, and here's that XML file. A quick edit, you can see we're only going to recover one database here. We've got this little database stanza right here, where I'm specifying the path to my MDF file, the path to my LDF file, and the database name that I want to recover this as. Well, again, important why we bind those drive letters to known drive letters, so our next step can successfully recover these databases. And we could do this for 1 or 1,000 databases if we make this script. We could also automate the creation of these XML files. I, of course, just manually entered in the couple lines of text needed for here. So let's jump back to that script, get that out of the way, and take a look. So again, we're going to read in that file. Once we read in that file, I'm going to import my SQL PowerShell module and use the attached SQL command here. And I'm going to tell it, use my master database, and create databases based on DB name, the file name for its MDF, and the file name for its LDF. I'm going to spit that out to my SQL server and write some status along the way. So let's go ahead and click our test pane. Again, target our hybrid runbook worker, as Azure cannot do this on its own, as it has no links into our fabric. And I'm going to choose the only hybrid runbook worker I have at my disposal. I'm going to start this script. It's going to queue. It's running, so it will pop right back over here, and I'll impatiently refresh. Oh, hey, it's there. I like when things happen quickly. So we could see our demo SandDB was recovered via our script. You can see that there's a database there. I didn't build any tables, it's just an empty object. But you can see this database recovered successfully inside of our SQL server. So at this point, our SQL database tier would be up and healthy for our environment. We could then jump into DNS, change some CNAME records to point to the SQL server, update any needed SPNs if that would need to happen, and continue down the line of bolting in the other tiers of our applications to make a service completely function. Well, we could add in different tiers at this point and do the same type of scripting. We could change bindings in IIS if needed, or update really any records. Then we have our entire infrastructure environment ready for failover with one click for DR testing, application testing, upgrade testing, whatever. Then as painlessly as we spun all this up, we've automated, it's repeated. We could do the same thing and spin it all down. We're going to go ahead and collapse this environment up. And we could see that we had some success reported on our DB script. And let's jump into our recovery vault. Take a look at our recovery plan. We could see that this item is initiated. It's the only recovery plan we have. And that it's letting us know our next step needs to be clean up a test failover. So that's what we're going to do. We're done testing. We've shown our scripts. We've done everything we needed. Make a note if you want to. Tell it testing is complete. Hit OK. And we're going to begin cleaning up this environment. And over the next 5 to 10 minutes, all the virtual machines we have that are running will be collapsed. If we had things like load balancers, more security appliances, any other SAN topology we needed to change, we could put that at the end of this failover script, shut these items down so we don't have to remember to turn them off and accidentally get that Azure bill that's, significantly higher this next month. So that is the end of our demo section today. Let me jump back over into that slide deck and I will open it back up for questions. Oh, and if there's any questions from the audience, you could please feel free to chuck them in the chat window and I will attempt to answer them. Or if I don't know it, I will give you the standard consulting answer of, I'll have to get back to you on that. Or honestly, you could shoot me an email if it's something that I don't know. My email address should be on the next slide here. I'll give everybody a couple minutes for questions, maybe another minute. Oops, I didn't want to do that yet. But there's my email address if you need it, and I'll show that screen again. I just kind of wanted to show you if the environment's wrapped up yet. And you can see all these items are in process. It's Azure, so sometimes it takes 2 minutes, sometimes it takes 3 minutes, sometimes it takes 10 minutes, but these items are slowly being cleaned up. Look at our test VMs. Oh, hey, they're starting to collapse. So we can see that they're deleting, all these objects are going away. We'll be reset for our next test run. So if our failover didn't go well, if there's something we missed in our application upgrade testing, we collapse it all quickly. We rerun this environment again, and we rerun our steps over consistently, repeatedly. And again, all of this while testing our actual DR practice. Well, let's sandbox those applications and let's do this a bunch so that we're really, really comfortable with this process and we know it works. So that way, if your primary data center does toast, you are going to feel as confident as you can be getting in front of this window and beginning failover actions to Azure. All right, still no questions from the old audience there. So I'm just going to jump to my final slide. No questions. All right, and seriously, thank you so much for joining on this presentation and all the rest. I really do appreciate you taking the time of your day to hang out with me and learn some more about Azure Site Recovery. If you have any follow-up questions to this demonstration, please feel free to email me at nick.taylor@model-technology.com or reach out to your sales partner, and we will set up possibly a demo or explain this further for your unique environment. Thank you so much, and I hope you all have a great rest of your day.